Find the speed associated with the following trajectory, and then find the length of the trajectory over the given interval. So here our trajectory is defined as vector r of t. We have 2t cubed minus t cubed, 6t cubed, and our interval is from 0 to 3. So the first thing that we want to do here is find the speed. So let's quickly recall that our speed is defined as the magnitude of the velocity vector, right? Or in other words, the magnitude of our tangent vector. So we'll need to differentiate this given trajectory and then find its magnitude. So r prime of t is equal to 6t squared minus 3t squared, and then 18t squared. So to help simplify our calculations, I'm going to go ahead and factor out a 3t squared, so our greatest common factor, which leaves us with the vector 2 minus 1, 6. So now we're ready to go ahead and find the magnitude. So we can keep that scalar multiple on the outside, 3t squared. And then this is going to give us the square root of 2 squared plus negative 1 squared plus 6 squared. So we have 3t squared multiplied by the square root of 4 plus 1 plus 36, which leaves us with a beautiful final answer of 3t squared multiplied by the square root of 41. So therefore the speed, the magnitude of that velocity vector, the tangent vector, is equal to 3t squared times the square root of 41. So now that we have this speed, we're ready to find the length, or find the arc length. And again, let's start here by recalling that our arc length S is defined as the definite integral from a to b of the magnitude of our tangent vector dt. So plugging in what we just found, we can say that our arc length S of this trajectory from 0 to 3, and then plugging in our magnitude, we have 3t squared times the square root of 41 dt. So you can go right ahead and integrate at this point if you want. I'm going to pull the constants out to the front. So I have 3 times the square root of 41 from 0 to 3, t squared dt. So let's give ourselves a little more room. So we're ready to integrate, and this gives us 3 times the square root of 41 multiplied by t cubed divided by 3, and we're ready to evaluate 0 to 3. So we can simplify here. 3 divided by 3 leaves us with 1. So you have the square root of 41 multiplied by t cubed from 0 to 3. And we're ready to evaluate. So I'm going to keep that square root of 41 on the outside. And this is multiplied by 3 cubed minus 0 cubed. So I have the square root of 41 multiplied by 27 minus 0, which leaves us with a beautiful final answer of 27 times the square root of 41. And since this is our length, we want to make sure that we add units.